rule we learned, right? What I want you to understand is that you actually did use the chain rule. You just didn't realize you were using it when you did it, okay? Just follow me for a second here. See my fist? I have my fist squared, right? My fist squared. What's the derivative of my fist squared? 2 times my fist to what power? The 1, yes? Times, now you take the derivative of my fist. What's derivative of x? 1, so there's a 1 there. Understand, you were using the chain rule, you just didn't realize you were. Let me do it again. X to the 5th, take the derivative. So I'm using chain rule. 5 comes out, the x to the 4th, right? Times, now the derivative of x is 1, right? Now I didn't, when we did the power rule, I didn't say that to you because you didn't even know what the chain rule was at that point, right? Now, the reason I'm showing you this is because now I'm going to switch to a different notation. I'm going to write this. Instead of that, I'm going to write d dx of x squared. That's, instead of the prime is always meant take the derivative, right? This is a different notation. We call this Leibniz notation. And the good thing about the Leibniz notation, the great thing about it, is that it tells you what the variable is that you're differentiating with respect to. So this tells you, hey, take the derivative of that, treating x like your variable. So let's go through the steps. First thing I'm going to do is the power rule. So 2 times x to the 1st power, right? That's the first thing, chain rule. I'm using power. Times, now I'm supposed to take derivative of the x, right? Derivative of x. So I'm going to write it like this. I'm supposed to take the derivative with respect to x of x. Does that make sense to y'all? Taking derivative of my fist squared, 2 comes out, my fist to the 1st power. That's okay? Then I need to take derivative of this thing. But I'm going to use the other notation. D dx of x, what should this turn into? What should it turn into? A 1, right? Well, it does. I mean, because isn't that just, if you just slide this x on top, isn't that just dx over dx and that's 1? So your answer at the end of all of this is just what? 2x. Now I know I know you're sitting there looking at that going, why are you making things more complicated? I knew the answer was 2x a long time ago, right? There's a reason I'm doing this, so just hang tight, all right? Let me do something a little different. Okay, if I did this, if I said, hey everyone, take sine of 4x, take the derivative. That's the way I've been doing it, right? Take the derivative of that. And we would get an answer. The answer to this would be cosine of 4x times 4. So you're taking derivative of the outer function. Derivative of sine is cosine. Don't touch the inside. And then times the derivative of the inside. Derivative of 4x is 4, right? Now, let's use a different notation. If I say take the derivative, treating x like your variable, of sine of 4x, we're going to follow the same format. First you start out cosine of 4x. But now I still need to do what? The derivative of what's in here, right? I need to take derivative of what's in there. So I'm going to write it as the derivative with respect to x of 4x. Now, yes, the answer to that's going to be 4, but I want you to see why it's 4. Cosine of 4x times this right here. Remember when you have a constant attached to the function, the constant comes for the ride, right? So I'm just going to write 4 because it comes for the ride. Now what I'm doing is I'm taking the derivative with respect to x of x. I have to take derivative of that with respect to x. And does everyone see that this is basically dx over dx, which turns into 1? I realize this is confusing you all. Like, I realize that when you're looking at this, you're like, why are you making this harder? Like I was just starting to understand chain rule, and now you're throwing this d dx thing in there, and it's making things confusing. Or maybe it's not. What do y'all think? Is it confusing? It's a little confusing, yes? Let me keep going a little bit here. Let me give you another example. What if I wanted to take derivative, treating x like my variable, of x squared plus x plus 1? What should the answer to this be? What should the answer to this be? 2x plus 1. And it is going to be 2x plus 1, but you need to understand why, okay? What we're going to do is we're going to take the derivative with respect to x of each one of these. See, I'm taking derivative with respect to x of each of these three pieces. Then what is, let's go from right to left because I think it's easier that way. What's the derivative of any constant, always and forever? 0. Okay, what's the derivative of x with respect to x? This is 1. And the way you see that is that it looks like dx dx, right? That's what this turns into, dx dx, which is a 1. Following? This one, I have to use the chain rule. So first I bring the 2 out, x to the first power times, now what am I taking the derivative of now? The x, right? And I'm going to write it as d dx of x, and I put a plus there between them. So I bring the 2 out, that to the first power, then I take derivative of the x with respect to x. And this again turns into a 1. So this just becomes 2x times 1 plus 1, so 2x plus 1, as you suspected. Like I said, I realize this is confusing, but now let's get to a real problem. All right, this was just to get you to see this chain rule with this notation. Let's go to this one right here. If x squared plus y squared equals 16. That is a circle, right? That is a circle, has a radius of 4. We already know that when you draw that, we have tangent lines at every point. All over this thing we have tangent lines. And we'd like to be able to find the slopes of those, right? Let's find the slopes of the tangent lines. So the question here is for you to find dy dx. Now, if you're unfamiliar with that notation, that is basically me asking you to find the derivative. This is the same as me saying y prime. It's the exact same thing. So if I'm asking you to find the slope of the tangent line, okay? But I'm just using a different notation to say it. Well, we already know that you cannot solve for y easily on that, right? You can't, because when you try and solve for y on this, you get a plus or minus. So what I'm going to do is not try and solve for y. I'm going to now use what is called implicit differentiation. So here it is. So the way implicit differentiation works is this. You take the equation and you write it down. And what you're going to do is you're going to take the derivative of the left side of the equation with respect to x. And then you're going to take the derivative with respect to x of the right side of the equation. So I start with this equation, and I differentiate both sides with respect to x. Now, the reason I'm saying dx over here, the reason I'm putting dx on the bottom of those is because in the original problem, I was asked to find dy dx. You know how the tangent line, right, is a line, so you have slope. You have rise, you have run, right? The rise is your change in y. That's what this represents. dy is your change in y. Your run is your change in x. dx on the bottom is your change in x. So this is basically rise over run. But infinitesimal because we're doing a limit because this is calculus. So this is basically saying find the rise over run, right? So this dx down here is just letting you know that the x is the one that's changing on the left to right. It's just keeping track of the variable, which is why I'm differentiating over here with respect to x. So whatever variable is down here, I'm going to write this. Whatever variable is down here, this is the variable we are differentiating with respect to. So when you hear me saying we want to differentiate with respect to x, we want to differentiate with respect to t, we want to differentiate with respect to m, when you hear me saying that in the next couple of weeks, that is the variable that appears on the bottom here. All right, you ready? Here comes the differentiation. I know you're confused. So let's just play this out. I'm about to take the derivative, right, of two things that are being added together. I can do them separately then, can't I? So I'm going to write that down. I want to take the derivative with respect to x of x squared plus, then I want the derivative with respect to x of y squared, and that's equal to the derivative with respect to x of 16. So I'm just using the fact that I can split this into two derivatives. Any questions yet? What is this? 2x. But let's play through why it's 2x. What happens? The 2 comes down, x to the first power, right? Times, now you have to take the derivative with respect to x of what? The x, right? And that's going to turn into a 1, right? So you do the power rule, and then the derivative of the base, not the exponent, the base, and you get that. That's going to turn into a 1. So this all just becomes 2x. All right, let's do the other one. Plus, pay attention. This is the part that gets everyone, right here, this piece. That was loud. Okay, I wanted it to be louder. That was kind of wimpy. Everyone paying attention? Yes? What's derivative of y squared? Power rule first. First, what happens? 2 comes down, right? 2 comes down. Y to what power? First power, right? Times. Now I'm going to differentiate d dx, but what am I differentiating this time in here? The y, right? The y, not the x. The y. Now, let's just leave it like that for right now. Equals, what's the derivative of a constant? Always and forever. 0. Okay. Look at the slight difference between these two things. On this one, 2 came down, x to the first power. Then we differentiated the base, right? The 2 was gone. So, like we did the 2 with the power rule. So then we said, look at what's the derivative of that with respect to x. dx over dx is 1, which is why it turned into this, right? Over here, though, the 2 comes down, y to the first power. Now we're differentiating the y with respect to x. Does dy dx turn into 1? No. dx over dx is 1, but dy over dx is not 1. What is it? Dy over dx. It's dy dx, but holy shit, that's what I'm actually trying to find. That's exactly what I'm trying to figure out. I'm trying to figure out what dy dx is, and it just appeared here, right? It just appeared. Which is the whole reason we do the implicit differentiation. Let me keep going, all right? The thing I'm looking for is in here. So I'm going to write down 2x plus, this is 2y, and be careful, that's a 1, right? Not a prime. That's a 1. And then this is actually dy dx. I'm going to write it like this now instead. I'm just going to push that y up on top, and then equals what? 0. Holy shit. I have what I'm looking for. There it is. This is what I'm trying to solve for right there. So I'm going to isolate that on one side of the equation now. I'm just algebraically going to move things around. Let me subtract 2x on both sides. Does anyone have a question? We're going to do more examples, of course. Right? Subtracted 2x on both sides. And then I'm going to divide. Let me do that. I'll do it right here. So I'm going to divide both sides by 2y. And I get negative 2x over 2y. And that just becomes negative x over y. So I have an answer. There it is. Who has a question? Come on. You'll have the look on your faces like you have questions, but no one wants to ask. We started with an implicit equation that we can't solve for y. We know that when we draw this, that's a circle of radius 4, right? We know that at every point here we have a tangent line. Yes? You have a question?
It's trying to flip-flop, so we can do that.
Okay. Okay. So we're trying to figure out, can we find the slopes of tangent lines? And what we did is we found a formula for it, right? This is the formula. What do I have to give you for you to be able to give me the slope of tangent line? What do you need? An x and a y coordinate, okay? So let me give you one. How about we go to the top of the circle right here? Can you all tell me what that point is on the circle? 0, 4. Okay, so the x is 0, the y is 4, right? What would the slope of the tangent line there, what should it be? 0? Does it work? Take 0 and 4 and plug it in this formula. Negative 0 divided by 4 is 0. Hey, it worked, right? How about this one? What's that point? 4, 0, right? That's your x, that's your y. What should the slope of this line be? Ooh, wait a minute, it's vertical, isn't it? Vertical lines have undefined slopes, right? Well, try and plug that in over here. Plug in 4 for x and 0 for y. You get division by 0, it's undefined. That matches with what's going on over there, right? How about this point right here? Right at 45 degrees. We actually don't know exactly what that point is, but do you agree that whatever this number is exactly the same because you're at 45 degrees? These two numbers would be the same? So if I take those two numbers and I plug them in right here, if those are the same two numbers, then what's my answer going to be? -1, right? -1. And does it look like the slope there would be -1? It would be. Make sense? This is like a master formula, and it gives us a slope of the tangent line at any point on that circle, so long as you give me the point. Give me the exact x and y coordinate, and I will give you the exact slope of the tangent line at that point. Do y'all see it or not? Let's do the next one. Let me do, before we do another example, let me get you to think about something. Because this part right here is the critical part. Like, you have to understand this whole idea now of differentiating, and then when we say with respect to, right? So if I say d dx of x squared, my answer is 2x times d dx of x, which is just 2x times 1, which is just 2x. I think I've done that example now 4 times, right? But what if I do this? Derivative with respect to x of y squared. Well, this would be 2y times d dx of y, which is 2y dy dx. And that time, this doesn't go to 1, right? That's the problem we just did right there, right? How about this one? What's d dy of y squared? What am I differentiating with respect to? Y. Okay, so now this chain rule, right? 2 comes out, 2y to the first power, but now I'm differentiating with respect to y, and what is it that I'm differentiating? What's the base here? Y. What's dy dy? 1. dy dy is 1, dx dx is 1, dy dx is not 1. So this would become a 1, and that's just the answer is 2y, right? How about this one? How are we doing? 10 minutes? So what's the derivative with respect to t of x squared plus y squared? What am I differentiating with respect to? What variable? T, right? T? What variables appear in here? X and y. Am I ever going to get something that turns into a 1? No, because I would need either a dx dx or a dy dy, wouldn't I? But here I have a t on the bottom. But let's go through it. Okay, first thing I'm going to do is, because I have addition, I'm going to separate it. I'm taking the derivative with respect to t of x squared plus now the derivative with respect to t of y squared. So I've got those separated. All right, someone want to go for it and tell me what that first one should turn into? What's the derivative of x squared with respect to t? Go ahead. 2x, that part I agree with, times dx dt. There you go, dx dt. That doesn't turn into 1. Plus, over here, 2y times dy dt. Because we're using the power rule, 2 comes out, y to the first power. Then you have to take derivative of y with respect to t, which does not turn into 1, it turns into dy dt. Y'all see it? Not seen it?
I don't get how everything's dy over dt and like dx over dt.
All right, so let me go one step before. If I have a box to the second power and I ask you to take the derivative, right? First thing you do is bring the 2 out and then you put the box to the first power. So here, this is the box, right? 2 comes out, that to the first power. You're okay with that part, right? Now, if you're doing this chain rule, now you have to take derivative of that, right? Yes? Okay, so now this, I need to take derivative of x. Normally, we would say derivative of x is just 1. But we're differentiating not with respect to x, we're differentiating with respect to t. So we're saying, what's the derivative with respect to t of x? That doesn't turn into 1. That's just whatever dx dt is. I don't know what it is. But it's not 1 because this is an x here and that's not an x there. If these are both x's, this turns into 1. But if they're different, then it just turns into dx dt. Yeah, it's like you're sliding this up top here. It's like if I took a fraction 1 over 1/2 times 3, you could like almost slide that up there and make that 3/2. That makes a little bit of sense?
Yeah.
And then over here plus, let's see, this is 2y, and then same thing. 2y, and then you're taking the derivative with respect to t of y, and that does not turn into 1, that turns into dy dt. Where's my problem? Where is it? I want to do that one. Okay. Let me write it down. How are we doing on time here? 10 minutes? So this one is x cubed plus cosine y equals x plus y squared. And I want us to try and find on this, the same thing, I want us to find dy dx. Right, so what I'm going to do, because I'm differentiating with respect to what variable here? X, right? I'm differentiating with respect to x because it's the one on the bottom. That means I'm going to come in and I'm going to take the derivative with respect to x on the left side of the equation equals the derivative with respect to x on the right side of the equation. All right. I have addition here, right? I can do these separately. I take the derivative with respect to x of x cubed. Then I add to it the derivative with respect to x of cosine of y. That should be equal to the derivative with respect to x of x plus the derivative with respect to x of y squared. So same thing on the right side. Since there was addition, I just did them separately. All right, who wants the first one? What's the derivative of x cubed with respect to x? 3x squared, right? That's just bringing the 3 down, powers 2, times, now you're differentiating the inside with respect to x. What is the thing you're differentiating here? X. So that's just going to turn into a what? A 1, right? So this is going to turn out to be your 3x squared that you thought it was going to be, right? Plus, okay, here, chain rule. We have an outer function is cosine, inner function is y. Start with the outside. What's the derivative of cosine of something? Negative sine. So I'm gonna put in parentheses, negative sine of y, right? But what do I still have to take the derivative of? The y, right? This y is inside this, right? So I now need chain rule to take the derivative of that y. What is the derivative times the derivative with respect to x of y? Is that 1? No. But it's what I'm looking for, right? It's what I'm looking for. I'm done with that derivative. Let me run through it again. I'm trying to take derivative of cosine of something, right? Derivative of cosine of something is negative sine of that something times the derivative of what's in here, but that means the derivative with respect to x of y, which does not turn out to be 1. Move to the other side of the equation. What should this be? 1, dx over dx, that's 1. Plus, what should this be? 2y, right? Power rule, right? 2 comes out, y to the first power, but now you still need to take derivative of that y, which is dy dx, right? I'm going to write it this way. So here's my answer so far. I'm going to rewrite this. It's 3x squared minus sine of y times dy dx equals 1 plus 2y dy dx. Do y'all see where everything came from there? Does anyone have any questions where any of that came from? You will get faster with this as you start to become more comfortable with what's turning into 1 and what isn't turning into 1. Now we still need to solve for dy dx, okay? I'm not going to do that part right now because we're almost out of time. I actually want to tell you what your homework is, and then I want to tell you a story. Story time. So I want you on 2.6 for homework. Don't follow the calendar on this. What I want you to do is just look at problems 3, 5, 7, 9. Just see if you can get the derivative, okay? What I mean is, if I want you to get to this stage right here, You do not need to go solve for dy dx and get it by itself on one side of the equation. Just see if you can actually execute the differentiation properly. Next class, I'll show you how we do that because there's usually a lot of algebra involved in that. All right, your test is when? A week from today, right? I'm going to send a review, something, and this what we cover today will be on the test, but nothing that we cover next time. Yes?
And then what's the beginning of the unit for this again?
What's the beginning? I'll give you the review. The review will give you some idea because I need to look at where we ended.
The review, are we going to get the review like by today or tomorrow?
Today or tomorrow. I'm going to try. I've got a lot of other things going on. Yeah. So I still have 3 minutes. I want to tell you all a story. This is actually a true story. It has to do with math. It's not random. But I'm not going to record this because there's no sense in it. So are there any of you that are planning on going to graduate school? A couple of you thinking about grad